In this video, we're going to be solving quadratics using the quadratic formula. So the biggest deal with solving using the quadratic formula is knowing what the quadratic formula is. So the quadratic formula, because when we solve a quadratic, we're looking for where it intersects the x-axis. So our formula starts out x equals, and the rest of the formula is negative b plus or minus. And remember, we're dealing with a square root, we're dealing with quadratics. So we have at maximum a possibility of two answers. When we solved by undoing, when we solved completing the square, when we took the square root of something, we had to have a plus version, we had to have a positive version, and we had to have a negative version. And then inside the radical, we've got b squared minus 4ac. That should look familiar. If you've done the work with the discriminant, that is the formula for the discriminant. So what we're going to do is we're going to let this problem tell us how many answers we should get before we even get to the end. And then we're going to divide all of that by 2a. So let's go over here and talk about the steps for solving using the quadratic formula, because we're not just going to plug it all in and then punch it all into our calculator as one big thing. So the first thing we want to do is we want to identify the a, the b, and the c. Of course, we want to make sure it equals 0. I've said that a million times, but everything I'm going to give you today is going to equal 0. So the first thing we're going to do is we're going to identify the a, the b, and the c. Then we're going to plug all those numbers in. We're going to use lots of parentheses because we're going to be dealing with positive and negative numbers and positive and negative signs in our formula. So we're going to plug everything in. Then we're going to simplify just the stuff that's in the radical. So we're going to simplify that discriminant before we start, because I want you to simplify the discriminant for two reasons. One, if you go ahead and simplify the discriminant first, you know how many answers and what kind of answers to be looking for. If you solve it and you go, oh, I have a negative inside the radical, then you know you should be looking for two non-real solutions. Or if you solve the discriminant and you get a 0, you know you're looking for one real solution. And if you get a positive number, you know you're looking for two real solutions. So solving the discriminant first gives you a heads up on where you're headed. Solving the discriminant first also is really necessary because your calculator is not going to deal with negative numbers well. Your calculator will spit out negative numbers when you put them in the radical. It'll just spit it out and say it can't do it. So if you were to try and plug it all in at once and it was a problem that had two non-real solutions, the calculator would go, you can't do that, you're not allowed, and you'd have to figure out why it was telling you that. And then the last thing we're going to do is we'll finish solving it, and we're going to write in set notation. So finish solve and set notation. So our first example is 2x squared plus 3x minus 5, and it equals 0. So our a is 2, our b is 3, and our c is negative 5. So we're going to plug these numbers with lots of parentheses into this formula. So x equals negative, b is 3, so I'm going to plug that in, plus or minus the square root, parentheses. Notice I'm putting parentheses. Every time I take a variable out and replace it with a number, I'm going to put parentheses around it. A is 2 and c is 5. And on the bottom, I'm going to say 2 times a, so 2 times 2 on the bottom. So the first thing we're going to deal with is the stuff that's inside the radical. So x equals negative 3 plus or minus, and then let's punch all of this in our calculator. So 3 squared minus 4 times 2 times, and that should be a negative 5. Let's put a negative in there so we don't forget. So negative 5. And we get that this is 49. And then on the bottom, 2 times 2 is 4. So we're going to keep simplifying. Negative 3 plus or minus the square root of 49 is 7, and it's all divided by 4. So we have a plus or a minus, so we need to do this problem once with a minus sign. So negative 3 minus 7 divided by 4 is going to equal something, and negative 3 plus 7 divided by 4 is going to equal something. I always put them in order from the negative first and then the positive. That way, I generally have already got my answers in order from least to greatest. So we're going to go alpha y equals, and we're going to pick number 1, and we're going to put negative 3 minus 7 in the numerator and 4 in the denominator. And we get negative 5 halves. And we're going to do the same thing with the positive version, the plus version. Negative 3 plus 7 divided by 4, which is 1. So those are our two answers. We're going to put them in set notation. Negative is smaller than a positive, even though that fraction comes out to like negative 2.5. Negative is smaller than a positive. So that's really all you got to do. As long as you know the formula, the quadratic formula, the rest of it's really simple. Just plug in numbers in and use in your calculator to get a final answer. Let's do a couple more examples. X squared minus 6x minus 7 equals 0. A is 1, so that understood 1 in front of the x squared. B is negative 6 and C is negative 7. So x equals negative. For B, we're going to plug in that negative 6 plus or minus the square root. Negative 6 squared, this is why, this B being negative is why it's really important that you use parentheses. 4 times A, which is 1, times C, which is negative 7. And all of that is over 2 times A. So we're going to go through and we're going to simplify piece by piece, but we're going to hit the inside of this first. Double negatives, negative 6 makes a positive 6, plus or minus the square root. And we're going to go negative 6 squared minus 4 times 1 times negative 7. So we get a 64 in there. And then on the bottom we get 2. 2 times 1 is 2. So we're going to say 6 plus or minus. 64 is a perfect square, just like 49 was in the first example. Square root of 64 is 8. So that told us, that 64 told us, hey, you're going to get 2 real solutions. So what we're going to get is we're going to get 6 minus 8 divided by 2 and 6 plus 8 divided by 2. So 6 minus 8 divided by 2 is negative 1, and 6 plus 8 divided by 2 is 7. So in set notation, my answers are 1 and 7. So those are the two places where my quadratic intersects the y-axis. Let's look at one where you get that non-real solution. So we've got 2x squared minus 8x plus 7 equals 0. So A is 2, B is negative 8, and C is positive 7. So x equals negative b, so negative 8, plus or minus, and then in the house we have b squared minus 4 times a times c. And all of that is over 2 times a. So right there we got negative 8, so that makes a positive 8, plus or minus. Now let's see what happens when we put this inside the radical, put that discriminant in our calculator. Let's get all the numbers in our calculator. So negative 8 squared minus 4 times 2 times 7. Oh, this doesn't come out as an imaginary number. I thought it did. Sorry about that. These are all going to come out having 1 or 2 real solutions. Wanted to do one that had an... So what was that? That was an 8. All right, this one is going to come out with a slightly unusual answer because 8 is not a perfect square. So what we need to do is we come over here and we do the square. So to do the square root of 8, we have to do that upside down division. So 2 and 4, which gives us 2 and 2. So we got a pair of 2's. So this equals 8 plus or minus. A pair of 2's goes outside. The leftover 2 stays inside, and we divide by 4. So before we even set this up as 2 different problems, what we need to realize is that you can't actually add these 2 things together because this one has a square root house and this one doesn't. These are real solutions. They're just real solutions that would have unending or really, really long decimals before they terminated. And rather than try to round decimals, we want to get an exact answer, so we're going to keep that square root of 2. Now, what we can do is we can treat this like 2 fractions, 8 over 4 and 2 square root of 2 over 4. So we can do some reducing. 8 over 4 would reduce to just a 2. And it would be 2 plus or minus. And this 2 square root of 2 over 4 would reduce to 1 square root of 2 over 2. Or you could just have the square root of 2 over 2. So you can, even though there's a plus and minus sign here, if both pieces will simplify, if the 8 over 4 will simplify and the 2 over 4 will simplify, you can reduce the problem, reduce the numbers if at all possible. So this one would become 2 minus the square root of 2 over 2 and 2 plus the square root of 2 over 2. It's a big ugly answer. It's not the kind of answers that you like to get, but it is the most exact answer for where this quadratic intersects that x-axis. So let's do one real quick that does have an imaginary number. So negative 5x squared minus 2x minus 8 equals 0. A is negative 5, B is negative 2, and C is negative 8. So we go negative, B is negative 2, plus or minus. B is still negative 2 squared minus 4 times A times C. It's a lot of stuff to get in there. All over 2 times A. So double negatives right there. So that's a positive 2. And then we're going to go plus or minus, and we're going to take what's inside the house. We're going to take the discriminant. Make sure we get all our parentheses. Negative 2 squared minus 4 times negative 5 times negative 8. We get the square root of negative 156. And all of that is over negative 10. All right, so first off, there's a negative inside there. Can't have a negative inside there. So we'll have to take that out. And 156 is not a perfect square, so we're going to have to simplify that. So we're going to say 2 plus or minus. We know we're going to have an I because that negative comes out as an I. And we know that 156 is not a perfect square, so we're going to go over here and we're going to do the upside down division of 156, which gives us 156 divided by 2 is 78. 78 divided by 2 is 39. And 39 is a perfect square. So I got a pair of 2's to go outside with the I. And I have a 39 that stays inside. And I have a negative 10 on the bottom. Now, you could write this as your answer. It is a correct answer, but it's not the most simplified answer. What we're going to do is we're going to treat this like two fractions. We're going to ignore this part, and 2 over negative 10 reduces to 1 over negative 5, and 2i square root of 39 over 10 reduces to 1i square root of 39 over negative 5. So we treated it like two fractions and we simplified. And as ugly as this answer is, this is your answer. This parabola never touches the x-axis, so we have imaginary answers. So we would put these in order, 1 minus 1i square root of 39, and you can leave that one out. You got to have this one, but this one could be left out, and you could just say I over negative 5, and 1 minus I, or 1i square root of 39 over negative 5. So that should be the positive one. The other one is the negative one. And those are the two non-real solutions using the quadratic formula. The quadratic formula and solving by undoing are really the only ways that you can find the non-real solutions. Factoring, which is the next video, will not let you find the non-real solutions. So you do need to be able to do the quadratic formula. I like it. I think it's the easiest one because I think it's very simple to plug numbers into a formula and then use your calculator to get final answers.